Sorry for the disturbance. Actually, the network problem has been happened. Anybody is not connected means you just share the link and tell them to connect with this. Thereafter, the problem won't persist. I think so. Okay, I'll go to the Ofdm technology. The Ofdm technology, I already told you, it has been segregated into multiple small speaker frequency spectrums. So the carrier can send multiple data in a particular time. Okay, so it makes the data to be sendable highly. Okay, so that is the ideology of Ofdm. Okay, so why OFDM is there? Why we have to go to the 5G? So I will explain you the concept whatever happened till now. I have spoken. First of all, from 1G to 4G, what we have seen, it's based on, it has been developed a more. But if you are seeing the 1G technology on the period itself, we have seen a TV channel, because the TV is a 1G technology. Now also we are seeing a YouTube also in the same data rate. But what's the difference? Because we are getting a same data rate at the particular 1G technology itself or in our home itself. But now also we are making a problems, having issues with receiving a data rate of 1 Mbps or 1 to 2 Mbps for HD transmission in a particular time is a problematic for us. Why it is happening? The exact issue is happens with the spectrum, because the spectrum is not available. The spectrum scarcity is there. Why spectrum scarcity is there? You might hear the radio frequency is only allowed from 0 to 3 gigahertz. After 3 gigahertz, it's a microwave frequency. What's the problem with radio frequency and microwave frequency? Microwave frequency can transmit from one point to another point. It is a visible communication. Like if a base station is there, means the base station can communicate with another base station. A base station is communicated with can communicate with satellite without any obstacles is there. The microwave antennas can communicate. The problem with our mobile phones are we can't able to communicate with a particular base station with a particular line to line communication. So we are communicating with the broadcast radio communication. But the problem with radio communication is we can 0 to 3 gigahertz only available. So the particular frequency range should be clearly utilized. That is the problem with OFDM technology. I can explain you these with an example, which has happened in a scenario about in Chennai. I will explain the further information. So I'll go to the 5G technology needs. What are the 5G technology ideologies? The 5G technology, it will be having a 10,000 times more traffic, and it will be having a million devices, and connected with that multiple devices. Why I'm telling the millions devices will be connected to the millions of devices connected means, because there will be an IoT technology. The IoT technology fully established. The particular device should receive about gigabit data. These are the problems. I will explain these with the problem happened in Chennai. So in Chennai, when I was in 2015, there was a heavy flood. In that situation, we can't able to communicate. If you want to communicate to my home or any other people, means I want to wait up to half an hour, because all the base stations have been covered with the water. So all the base stations can't able to utilizable. So only utilizable base stations network are working with the Airtel and BSNL. I remember that. So with the Airtel and BSNL, I communicate also. And when I'm going to make a call, it is making half an hour up to delay. Because why it is happening means, like me, all the users have been pledged in a particular network. So what is happening? The network is making a queue. So the queue is progressing one by one. Devices are available progress, but the same problem can be eliminated on the particular period itself. How can be eliminated? The elimination can be happened with the 5G technology. The 5G technology so that only proposes the frequency is in that period only the 2G frequency is used for the communication, but other frequencies also there, like Wi-Fi, otherwise like 3G communication, GPS frequency and TV frequency and radio frequency and Bluetooth frequency. All the information can be passed on these frequency also, but it is not utilized. Why it is not utilized? Because the network, the programming has been done with 4G up to 2G, 3G or 4G also can communicate with the particular frequency only. If the frequency is not there, we have to wait until the particular frequency has to be enabled by the server. So until that, we have to again work, and again it is reached, we can again communicate. If it is not so, we can't be able to establish the communication. That's the problem with 1G, 2G, 3G and 4G. So the problem should be eliminated in the 5G technology. So 5G technology proposes multiple device communication. So why it is proposed multiple? Because in future any fan will communicate with the AC will communicate with the TV will communicate with the cell phone will communicate with the any other X devices. So why I am telling these things means, because the network has to be established in a minute manner, and each and every home will be established the same IoT protocol. The same IoT protocol for established for every homes means every home will have the same issue. So every home will have a multiple frequency occurring. So automatically from one device to another device, it won't be happening in a proper manner. So for that only we are going to analyze with the 5G technology what's the problems and novelties have been proposed, and in the novelties what the problems should be identified, and the problem should be how to be acknowledged and analyzed, and how to reach a maximum solution is the progress should be analyzed in the 5G. Okay, so next I will go to the applications of 5G. So here I have shown the application of 5G, which is having a majorly the IoT and high data communication and autonomous cars, and after the education e-learning system now we are doing with that one, and after the smartphones and virtual reality and healthcare systems nowadays it's happening with geo communication based on video calling based healthcare systems are started. The same thing will be happening in future also, and the official systems will be there, and that also will be in a communication based on these technologies. So this is 5G ideology proposals. Okay, so what's the problem with the other frequency spectrum? I already told you clearly. So these are the problem. The same thing only should be analyzed. Okay, so here we are going to analyze what the future frequencies are available, can be utilizable also, but what's the problem also. So here it is having a radio frequency and a microwave frequency. We are seeing the radio frequency only utilizable for the network transmission, but microwave frequency is not utilizable. Okay, so that only is shown here. The technology evolution I have already told you, 1G, 2G, 3G, 4G, and what are the frequency bands have been explained. Why I explained the frequency is not available, I told already. The thing is here only, if you are seeing all the technologies like WLAN, WiMAX, WJ, TDD, FTD, FTDD and all, it is a 4G communication, and WCDMA is a 3G communication, and after that if you are taking GPS it's 1.6 GHz, GSM is 80 MHz, GSM means 2G communication, WCDMA is about 3G communication, and TV communication are happening within 500 MHz, because if you are seeing on TV channel it will be having 600 MHz bandwidth. So initial from 0 to 500 MHz allocated for TV. Sorry, 700 bands allocated for TV. These are the frequency bands allocated to all the users. Okay. Here is a map shown for the 2G, 3G, and 4G available in the world, overall world. This census has been taken on 2015 period. So when it is came into account, India has been acknowledged with 4G communication, and other countries also in China, Russia, and Australia, and after that American countries, after that South American countries, North American countries, all are deployed with the 4G communication. If you are seeing the green color shade shows that it is deployed with 3G communication, and GSM communication is also there, which is like we can see with this technology how the countries have been getting growth. The growth shows here. If you are seeing the green and yellow regions, there the network deployment is less, because they come. So to that, I will explain the OFDM. So what do you mean by OFDM? Orthogonal frequency division multiplexing. So if you are taking the orthogonal frequency division multiplexing, so what is happening? So previously the data has been transcended in a bulge manner. So now we are going to send in a small packet based analysis, small channel based sending. Okay, so which makes a channel is dropped also. If one truck, just consider here, if you are having a loading a water with one truck and you're sending, means the truck is full, means the overall water, the data fully lost. So the same thing here, if you're seeing the truck is sending, means this one truck is lost also, it won't give us a loss for the overall information. So the data can be transmitted moreover. So that's the ideology about OFDM. So what's the difference between FDM and OFDM? It's having a God band, and the God band is not available here. The frequency has been, channels have been interrelated. So the particular channels, if it is affected with the nearby channel also, there won't be any interference due to the orthogonality ideology. So here it shows what's OFDM has been acknowledged. It is having different phase shifting signals. These signals will be joined to make a one signal. So if the phase shift is happened also, the signal is joined also. It won't make any sense. So multipath fading next is multipath fading is happening here always in the communication. It is happening with relay fading and Retian fading. So fading, when the fading will happen means if you're sending information, it will be distorted with multiple path propagations. The same thing will happen in the OFDM also. So because it is having much more frequencies also. With that much more frequency it is sending also, the signal won't be received proper to the particular at the another end. So which will makes the signal to be received not properly. Like if I am sending hello information as a message, the hello should be received at the another end properly. If it is not received properly, like so we have to again resend it. Okay, that is a problem. So here in the we are using a guard interval. So what I mean by guard interval means in OFDM we are using the O. Hello is there means O information to be in the front. So what will happen if the loss is happening or delay is happening? Also the O will be lost. We will be sending again the hello message. So the signals are sending within multiple paths or multiple informations also. The path is changing also, it will receive in a proper manner. So for that only guard interval has been inserted. Okay. So after that OFDM blocking transmitter, it is having modulation scheme. It is like POA modulation or PA modulation. I will be explaining that one. So after that it will be having a transmitter like IFT transmission. For IFT is a inverse fast Fourier transformation. You might study in the DSP. So for multiple signal propagation, for multiple carrier phase shifting is there. So only we are using IFT. After the channel will be sent to the media. In that media it will be affected with the noise, with the channel feeding, and after that it will be received, and it will be after reception it will be removed. The cycle will be removed and it will be demodulated. Okay. So processing flow, it will input frequency signal will be taken under the modulator, and then after that while modulating, after modulating IFT is applied. IFT is applied means due to the IFT automatically the signals will be segregated in multiple phase shift keys, and with that phase shifting signal will be propagated and the channel response will be received again, and it will be inverse process like there we are using IFT, here we are using IFFT, and the final decoding will be happening of the data. Okay. Okay, 4G LTE, 1B 4G LTE. 4G LTE initially came by the year of 2015 when it was proposed by Airtel and Jio. Airtel told that LTE is the fastest network, we are at the fastest network. How it happened? So how it happened means the LTE technology will make multiple frequencies should be gathered in a particular user. It will be pipeline. The pipeline means what are the frequencies are there? It will be always won't be allocated to all the users. So if the user is not available, we can change that particular data into be reusable to the another user. So the pipeline data will be collaborated and joined to the received to the another user. So we will make the data rate to be increased. For that only the carrier aggregation technique is used with the LTE. Okay. After that LTE mimo. Mimo is the technology happens with the multiple antenna transmission. So multiple antennas will be placed. So the multiple antennas will make the signal to receive to the multiple antennas again. So when it is makes multiple antenna to be multiple antenna, here will be having a multipath propagation. Multiple channels can be created. So the signal will be efficiently transmitted to the one end to the another end. Okay, so the LTE MIMO technology is proposed. LTE automatically the use of data rate throughput has been increased by double the rate. You can see that when the blue color shows the what's the data rate is available earlier, and when the LTE domain is came, the particular data rate has been improvised by the double the rate, and due to that load can be also improvised. The user also can be increased. How much users are available, we can improvise that one also, which makes the particular LTE particular technology to be efficient. Moreover, and the LTE bands aggregated. LTE has aggregated up to 44 bands. LTE technology, which is available to the TV band, and after that, if you are seeing the 850 MHz frequency is there, GSM frequency is there, after that 700 frequency is there, and after that it is having a 2600, 300, 500. So it is having a wide range of frequency. What is the LTE ideologies means? LTE means long-term evolution. The LTE is planned to propagate all the data right into a mobile device, and all the data. Like in future, the communication won't be happen from the satellite-based communication, like dish TV communication. It will be happening with with the fiber optic, otherwise internet-based communication. So all the internet-based communication, local area communication is happening means the device frequency all should be aggregated in liberated manner. Furtherly, LTE developing the long-term evolution technology is developing the ideology about liberation of these frequencies. That is shown in this segment. So here I am showing the LTE bands aggregated in different countries. This is a Qualcomm's information passed on the year of 2017. So in this, if you are seeing North America, what is the frequency? The same frequency won't be aggregated in India also and other countries. North America on frequency, Europe on frequency, China on frequency, South America, South Korea on frequency, Japan on frequency, and Australia on frequency, South America on frequency, India on frequency. The different frequencies will be allocated. So that is shown in the Qualcomm slide have been shown. So the carrier aggregation can be happened with not only licensed spectrum like 2G, 3G. It has been can be happened with Wi-Fi frequency also. That is shown in this slide. Okay. So next is TDD, FDD. TDD means the time domain duplex, and FDD means frequency domain duplex. So the same thing, what we have discussed earlier in the TDMA consoles and the FDMA consoles. The same thing only here also available. But the 4G can be deployed with both the domains. That is only explained here. In India, we are using the FDD based domain. Okay. And after that, mimo beamforming. Mimo beamforming is the ideology about multiple antenna transmission. Whenever you are sending information, if I am speaking towards you, you'll be getting the signal efficiently. But if you are sending information towards another angle, it won't be received to another frequency, another user efficiently. Okay. So what is happening here? The signal wherever you are available, it should be received in a proper manner. For that, we have to use a multiple antenna technique. Multiple antenna means multiple device, one device with multiple signal processing units. Okay. So what will happen in any angle you are available, automatically the network establisher, like you consider, like if in your home you are having Wi-Fi router. The Wi-Fi router is there means if you are in a first room, in the Wi-Fi router is in the second room, you can't able to receive signal proper. So if you are because the signal is propagated in all the angles, so one propagation area won't be accumulated highly. So the MIMO is the ideology about how to establish signal whenever the user is available in a particular angle. So multiple antennas will be propagated in the same MIMO device, MIMO with Wi-Fi device. So with that, any user is available in any angle, based on that signal will be propagated. So in the example of the MIMO, so multiple antennas based on one router. The router can transmit the signal wherever the particular device is available. Here another router is there, another laptop is there also. The router can transmit only particular point, so it makes the signal efficient. So the laptops, the devices can receive the particular information in an efficient manner. For that only it is established this like. So the same thing, today's Wi-Fi what is available and futuristic Wi-Fi technology what will be there. So these can be established with CISO, CMO, MISO, MIMO. Like CISO means single input, single output. Nowadays we are doing that one. So single device is received, one single antenna. CMO means single input, multiple output. Multiple output means here these can be established in our Wi-Fi routers. Wi-Fi router, it will be establishing one signal towards all the people. So single input, multiple output. MISO means multiple input, single output. Multiple input, single output means it will be happening in our mobile devices. Mobile device try to gather multiple frequency antennas to receive the signal, and it will be sending the only information through one antenna. So with that we can receive all the other devices. MIMO is established in futuristically all the devices. Okay, it will be like whenever you are sending from base station, MIMO antennas will be placed. So the MIMO antenna can be received in the multiple devices also, in the receiver mobiles also. Okay, so that is the ideology of MIMO. Okay. So the same architecture have been shown with the data right, what is received with the multiple antennas, and then multiple input, single output, and single input also multiple output, and single input, single output. So we are showing that MIMO antennas makes a better establishment of data rate. Okay. So coordinate networks. So CRN is the technology of coordinate networks. So while doing that switching the network, the another network should be analyzed, because the another network should have the frequency. So how should be analyzed with the CRN technology? That is called CRN ideology. So this is spectrum allocation of United States charts, because why I am saying United States chart means we are using a United States ideology only till now. From initial onwards till now we are using the same technology. So this makes all the frequencies has been segregated to all the users. That is shown in this chart. Okay. So coordinate networks I explained you clearly initially. So if it will be having a primary user network which I am paying, like if I am using a Geo or anything, means I am paying the particular network. It is a my network. That is called a primary user of the particular network. I am the primary user of the particular network. If I can't able to establish a signal with the primary user network like Geo, I can't able to connect means I will be connected to the another network. So the connecting with the second another network is called secondary user network. Okay, so that is called secondary because I am a secondary user of the particular network. If I am communicating with Geo, it's not possible means I am connected with the Airtel. It's a secondary user. I am a secondary user for Airtel. Okay, so that is a consideration of CRM. So how can be connected? So here with the particular opportunity spectrum sensing concept with the quantitative, we can establish the freely available spectrums at the particular time to the secondary users. If you are seeing secondary user, one will be allocated to the blue color and secondary user 2, 3, 4 like that. We can allocate free spectrums for the other users which they don't have signals. Okay, so next is due to the cognitive network, how the spectrum has been utilized, that is shown here. Finally, mimo can be used with the cognitive networks also, and due to the cognitive networks, I will explain you with the signal will be received properly. So it is in a licensed or unlicensed spectrum, it can be received properly. That is the ideology. So I will have some demo about these. We are using and I'm proposing means because the network is in base station is at the center means the user might be left side or right side, any angle will be there, in any distance also will be there. So for that I'm randomly proposing a two primary users and secondary users, two types of users, and after that I'm showing that environment, and after that I'm showing that environment with the colors, which visibility colors I'm creating, and after that femtocells like small network cells I am creating because multiple base stations with multiple like Wi-Fi networks and base stations are there means how should be created. The same network should be created with the multiple base station networks availability. So with that, finally we are going to analyze with the channel capacity. So for channel capacity we are using a water filling with Ofdm. So the water filling with Ofdm and show that particular coding within that. We are initially making a channel allocation, the power allocation. With the power allocation, we are checking whether the power allocation is available or not. So if the power allocation, the particular position of the particular primary user is out of the particular distance, I'm just considering the distance to be 0.3. Okay, so the 0.3 is the major distance, and above the distance it's going means the primary is not available in the particular network I'm considering. So if it is not available, automatically the power should be analyzed. The accumulation of the power should be analyzed. The power accumulation, power to all temporary information has been analyzed. So with that information, I am going to calculate the channel capacity, and the power will be boosted reverse to the particular original primary user. The same primary user count will be analyzed. If the primary user count is lesser, automatically it will be analyzed to the secondary user also. So for that only this network coding has been established. Here if you are running the code means this in this we are seeing means initially the spectrum has been allocated with 4 channels, so 4 by 4 it will be 16. So the power allocation initially starts with only with the primary user channel allocation randomly. So that if you are seeing means the power allocations happens with only primary user. When it is going above the 9th channel, the channel is analyzed, the overall channel has been analyzed with the particular initial 8 channels. If the 8th channel has been analyzed, and with that power is gradually manipulated, and after that it is equalized to the further upcoming information. So what is happening means in this we are seeing the 10th and 11th channel is allocated to the lower power for the primary user because primary user count is lesser, the data is accumulated to the primary user is lesser, automatically the power has been equalized to the secondary channels. Okay, so that is a information has been passed, so that equalization is happening. Okay, so these carrier with the information with the noise and analyzed, and it will be equal to the other users. That for that only here it is proposed. Okay, So uh, here is the coding. So today we seen about the technology about Ofdm, we have seen about information about CRN also and LT also. I'm going to complete the session. I'm ready to answer you now. Also, you can ask me. Any doubts? If you can ask me. Otherwise, I'll close session. Actually, 5G communications. Welcome, Mr. San Tata. Actually, 5G communications, how it will be effective means it will be having a spectrum will be allocated to all the users, and devices enabling will happen, because now IoT devices not coming in full-fledged manner means it is happening due to the 4G communication inavailability of spectrum. So that can be managed with the 5G communication, that will happen for sure. And without seamlessly we can send any information to any user. Today's channel bandwidth scenario, actually today's channel bandwidth scenario is and that is not an issue, because nowadays also we are using a 4G technology. Actually the issue happened with the data rate slow up down, like it is happened due to I'm in a remote communication remote area, so signal has been dropped. So again I changed my room, and after that only I started the communication. So that only that scenario happened, Nidhi Sharma. 5G communication won't be proposed to the all the like base stations. It won't happen. 5G communication, all the nodes will be proposed in the each buildings. Okay, Mr. Ramesh Marela. So the all the devices, 5G devices will be placed in the transmitters will be placed in the buildings. So due to that, the signal propagation will be effective. So the cost is based on requirements, because the users are highly available means for the particular building we have to pay accordingly, and we have to get the device. Every building, like every street, every home, you can check with the E node B. Bandwidth is same. The how much will be applied. Okay. Join with